Hello everyone. First of all, I would like to thank you for giving me this opportunity to prepare a demo video. Myself Abhishek Kumar Shah and I am preparing a demo video for Standard 9 and the topic for that is structure of an atom. So let's jump to the topic. So the first thing that comes to mind, what is an atom? According to Dalton's atomic theory, it is the smallest indivisible unit of any matter. But is it really indivisible? I hope you all heard the term electron, proton, and neutron. These are the subatomic particles. So, an atom is divisible to electron, proton, and neutron. So, this story begins in 1886 when the Goldstein discovered the proton. He discovered new radiation in gas discharge called canal rays and later termed them as proton. After him, in 1900, J.J. Thomson discovered electron in cathode ray discharge tube experiment. So, after the discovery of electron and proton, scientists around the world in the late 19th century started to discover how these electrons and protons are arranged in an atom. What is how the atom looks like? What's the model of an atom? So lots of theories and models were proposed by different scientists, and among these the first one was J.J. Thomson, who proposed the very first model, and it's known as Thomson's model of an atom. So he actually said his model describes that an atom is a positively charged sphere in which electrons are embedded into it, and the second feature of his model was that the electrons and protons are equal in magnitude. That's why an atom as a whole is electrically neutral. You can think of a watermelon where the red edible part is proton and the seeds are like electron which is embedded to it. So this was his concept, but his model could not explain the results of various experiments carried out by other scientists. So after him, Rutherford model came. So Rutherford, what he did, actually he took a very thin gold foil and alpha particles. He made alpha particles to fall on the foil, and he observed some. He made some observations. So what were those observations? The first observation is that he saw that most of the alpha particles passes through the foil. Secondly, some alpha particles are deflected, and the third is that very few alpha particles, like you can say 1 out of 12,000, is rebound. That means it's deflected by 180 degree. So based on his observation, he made some certain conclusions. The first conclusion is that the space in an atom is empty. Most of the space is empty. That's why most of the alpha particles is passing without any deflection. Secondly, few alpha particles are deflected because there is proton which occupies very positively charged proton occupies very small space in an atom. That's why few are deflected. And the third conclusion is that since very few atoms are deflected by 180 degree, it means that the positively charged protons and the mass of the atom occupies very small volume in the atom. So based on these conclusions, he described his atomic model, which has some features. First is that an atom in an atom there is a positively charged sphere called nucleus, which is present at the center of the atom. Secondly, the electrons revolve around this nucleus in a circular path. And third is that this nucleus is having very small size as compared to an atom. So this was the features of his model. So if you see here, it looks something like this, that these are the this is nucleus, this is atom, and these are circular paths where electrons are revolving. Okay, so I hope it's clear till here. But his model also has some drawback. The thing is that he said electrons are revolving in circular orbit. Okay, we know in circular orbit there is continuous acceleration, because you know na, acceleration is rate of change of velocity, and at every point there is change in direction. So when a body is accelerating, it radiates energy. So if an electron is revolving in a circular path, it's continuously radiating energy. So as time passes, its path will shrink, and ultimately it will fall into the nucleus. So electrons is ultimately falling into the nucleus. But if this is true, then we could not see the matter around us in which form we are seeing it now. So actually this is not the case. We know matter is quite stable. So after him, Niels Bohr proposed his atomic model, where he said that in an atom there is some special orbits are present which are called discrete orbits, and secondly the electrons are revolving only in these discrete orbits. So this was his model. So in this way he explained that how electrons in an orbit is stable. So in 1932 Chadwick discovered the neutron. He said there is another particle which is called neutron, which is similar to proton and having mass similar to proton but having no charge. So these proton and neutron together constitute the mass of an atom, and electron is comparatively we neglect its mass because it's 2000 times a proton is 2000 times heavier than an electron. So this was all about the structure of an atom. And if this is the nucleus, these are shells. You can name this as N1, N2. These are like K shell, M shell, and in each cell there is 2n to the power square. This many number of electrons can be occupied in a shell. If n is equal to 2, then it is 8 electron in an orbit. So, and there is one more rule that in the outermost shell the electron can't be more than 8. So this was all about structure of an atom. I hope I am able to make you all guys understand. Hope you guys enjoyed. Thank you.